you guys. So I thought I would experiment with recording a video for you where I am solving a sample problem. And I don't know a lot about how to screen record, so I hope this works. And I would love for you to let me know if you find this useful, and I will try to do more of this for you. Okay, so this problem here is from a very old provincial exam. So it says a solution is found to contain a concentration of lead 2 plus of 0.10 moles per liter. What is the maximum concentration of sulfate ions that can exist in this solution before a precipitate forms? And you are given 4 choices. So the problem would be presented like this. Oh, those boxes are not formatted very well. Let me just put a line under here just to kind of separate where the problem is finished. Okay, and so this is where I'm going to put my work. I've already looked up the KSP value of lead to sulfate from the data sheet, and this data sheet is the one that you can find in your workbook for this topic. So the value's there. I will also be posting this file with the problem and the solution on Stellantis so that you can have a look at it in more detail. Okay, the 2 main steps for a problem in the solubility unit is to use the balanced equation for the equilibrium and to use the KSP expression. So let me write out the equilibrium equation. The solid we are dealing with is PbSO4, and that is in equilibrium with Pb2 plus ions in the aqueous state and SO4 2 minus ions in the aqueous state. Okay. Let me also write out the KSP expression. So that's going to be equal to the concentration of lead 2 plus ions times the concentration of sulfate 2 minus ions. We would normally divide by the concentration of reactants, but because your reactant is a solid, it does not get included in the KSP expression. And the exponents on these terms here is going to be just 1 because the coefficient in front of the 2 ions is also just 1. All right, let's take a look at the expression and figure out what our unknown is. We know the KSP value from the data sheet, so let me put that in. Okay, and so it's going to look like you have 2 unknown values until we go back and look at the information we're given in the problem. All right, it said a solution is found to contain a concentration of lead ions of 0.10 moles per liter. So that's going to give us this concentration here. Let me plug that in as well. Oops. 0.10. I'm not going to put units there right now because KSP has no units, so it's not really necessary. Okay, and so from here, it's clear now that we have just one unknown, the concentration of SO4 2 minus in the equilibrium situation. So that would be in a saturated solution. And let's just be clear on what you're really being asked for. It says, what is the maximum concentration of sulfate that can exist in this solution before a precipitate forms? So that corresponds to a saturated solution because that kind of solution has the maximum amount of ions present, and then adding any more of the ions would cause a precipitate to form. So it's asking what the concentration of sulfate is at that maximum amount of ions before the precipitate forms. In other words, it's asking for the concentration of sulfate ions in that equilibrium situation, and you are given the concentration of lead. Okay, if we're solving for the concentration of sulfate, you're going to be taking the KSP value and dividing by that 0.10 value that is from the original problem. Okay, And, oops, I'm just doing this on the side. All right, I guess I didn't really need to go to a calculator for that one because this is just multiple of 10. All right, so that gives us that sulfate concentration is going to be 1.8 times 10 to the negative 7. That's a superscript, there we go. And the units are moles per liter. So that corresponds to answer C, which is the correct answer for this problem. So that is your answer there. Okay, so I'm gonna just write a complete sentence to finish this off. So therefore, the maximum concentration of sulfate that can exist in the solution before a precipitate forms is 1.8 times 10 to the negative 7 moles per liter. All right, so there we go. There is the problem with the answer from the multiple choice and the full solution. Again, I will post this on Scalantis for you as well. I hope that was helpful to just hear my explanation verbally. Please do let me know if you would like me to continue doing something like this, or if you have any suggestions for how I could make this even better and more helpful for you.